This plane is just for clickbait. The FPV head tracking module I used is the Batshar Trinity head tracker. I'm pretty sure it's sold by Immersion RC. I bought it on Get FPV. But the way that it works is it sends out the pan, tilt, and roll signals through a trainer cable to your transmitter, and then your transmitter reads it as a trainer transmitter and then outputs those signals to servos on your airplane. So if anybody was wondering how that aspect of it works, there you go. Now on to my explanation video. Alright, hello YouTube and flight test fans that asked for it. Today I'm going to explain how I did my FPV head tracking on the F15 here in that video I posted recently. So what we got here is a custom pan and tilt setup, and all it is a modified servo on the bottom there that can turn almost 260 degrees total, I think. And then we've got this servo that's set up to be held by these two posts. So we've got pan and tilt, just like that. The tilt servo is actually the thing that moves, and I just glued the camera to the servo. Yeah, so the way I did that here is I supported the arm with a push rod and then reinforced with a bamboo skewer. Same thing over here. And then on this side, I did another push rod. I actually melted into the back of the servo so that it had a hinge or a pivot point, and then reinforced it there, and did that all on a base. Then I offset the base to the back and put the central pivot point here, because what I found is when I put that pivot point in the center of this base and the camera was out to the front, it actually had this sort of like long turn effect rather than just a rotation, you know. So it was a little bit disorienting when I did it that way. As soon as I got it so that the camera is actually where it pivots, it felt a lot more natural, and it was actually pretty intuitive, especially when you're bringing it into land. So if you're going to build one of these, I would recommend that. Make sure the camera is what's rotating, not anything else. The camera is the most important thing. So the way that I modified that servo, it is a standard Tower Pro, like the cheapest $2 servo piece of crap. I mean, it's good enough for like flying a cheap airplane you don't really care about, but not good enough for anything where you need precision like this. So I bought these resistors. These are 2K. I actually ended up using 3K in there, but 2K worked almost exactly the same. And what you have to do is take apart the servo, and inside each servo is a potentiometer. You can watch Flight Test's video on it, they explain it well. This is the potentiometer. Here's another one. Whoa, if I know where my hand is. They have 3 outputs, and that's basically to tell the servo circuit board chip where the arm is on the servo, which way the arm is facing, so that way the servo knows which way to spin the motor to get it to face the way they want, or it wants, you know, based on your control input. So the way that you do it is by cutting the outside 2 pins, separating the connection, putting a servo in between the connection of the potentiometer to the board, only on the outside 2. So 2 servos, or 2 resistors per pan servo. Then you leave the middle one intact, put it all back together, and you should, depending on the resistance servo or resistor you use, get more throw out of it. A lot more throw. But the biggest problem I had modifying these cheap servos was if there was any kind of drag on the camera, pushing it downwards like that, and also just the weight by itself of the camera, it would turn to 45 like normal, but then as soon as you try to go past, it'll go to about 180 total or 90 degrees, and wouldn't go any further, even though I knew that it could. And so what I ended up doing to solve that issue was I built this base here that holds up the rotating base. They just slide across each other, so that way when the air is pushing on this thing, it's pushing down on the base, which is actually mounted to the servo instead of the arm. So it's kind of transferring that energy, and then I could get the full rotation, look back and see the wingtip from all the way all the way up here, see the wingtip. So that was pretty nice. That was really nice. That's my favorite part. But it's just super finicky. I would not recommend modifying a dirt cheap servo like this. It sometimes it would go past the looking backwards and actually spin all the way around like twice, and then you get a jumble of your wires getting tangled around the camera, and that's no good. And the other thing, in the video you probably noticed that I could look further to the left than I could to the right, as I could see the left wing but I couldn't see the right. That was different every single time I plugged it in. And it never centered well either, because they're just, you know, they're cheap servos, nylon gear. So what I would recommend, instead of using those servos, I would recommend you get this one. Now this is a servo from FPV Model. It's about the same size as a regular 9 gram we use, except I think it's 12 gram. And that's just the weight, if you don't know. So this servo is metal gear, and it's a 260 degree right out of the box, which means it can turn all 260 degrees without any modification, and it's got precise movement inside that range. This is the one that a YouTuber by the name of aussiehoppy uses, and he's actually my inspiration. He makes the most amazing inside the cockpit head tracking videos. I really strongly recommend you go look him up. He doesn't have a lot of subscribers and he deserves more. He's really cool. That I talked to him, I commented on one of his videos, that is the servo he said to use. So if you want smooth video, there's your servo. This is what I'm going to use as the pan servo, in a similar setup but not quite the same. Mainly because it's smaller. You still get nice precision out of it. That's just a really cheap, like $4 3.7 gram off of Banggood. But you get decent precision, and it'll definitely be good enough for tilt. I don't know how it's going to work with the weight of the camera, but I'm going to be using a lot smaller of a camera. Just a regular CMOS type of thing. But what I'm going to do differently when I build the next one is I'm going to have this servo arm, if I build it this same way, I'm going to have this servo arm facing forward instead of back. Have the servo actually kind of centered or offset to the left instead of the right, so that the arm can go forward, and that way it just makes this whole base smaller. And the idea with making it smaller is so I can put a pilot head, like one of the little minifigure pilots, the fake pilots, around the camera and make it look like there's still a pilot in the airplane that's just looking around. I feel like that would be cool, but I don't know, you know, that might not happen. The video transmitter. It is the TS832S from Banggood, Aomway antenna. Pretty nice. I get good range. It's like $10. It's not that expensive. This f15 is about 8 years old. It's the E-flite f15, and one of the motors actually burned out. It caught fire just after I had stopped recording that video that I posted. So it doesn't fly anymore, needless to say. So what I did is I went and bought an E-flite Commander, and I'm going to build with those two servos as soon as the new camera ships. And I'm going to make it inside the cockpit best I can, head tracking with higher quality servos. It should be a much better video, so look forward to that. If there is anything I missed, anything you guys wanted me to show that I didn't, please let me know. I can post pictures or whatever you need. So here I'll try to, you know, kind of hold it up, show it from all angles. So yeah, there you guys go. Again, let me know if you got questions or comments, but this was the FPV head tracking. Thanks a lot, guys.